loud? They're literally breaking the door down. Au moins c'est enregistré, ça servira à quelqu'un. Should I be swapping slides?
No, if you say
Use slideshow?
yeah, then use
Got it. There we go. All right. All right. Welcome, everyone. This is going to be a talk about instrumenting your DNS using some open source tools that are maintained by the DNS OARC. My name is Phil Rognot. I work with DNS OARC, and I've been doing this now for a few months, but before that I was working with the Network Startup Resource Center, and I've been doing DNS deployments, engineering assistance for CCTLDs and registries around the world for the past 15, 20 years. And one of the things that often comes up is how do we monitor our DNS? So therefore, this session for Apricot 2024. This is going to be a mixed format. There's going to be some slides. I hope there's going to be some questions, a bit of interaction. I'll have some things I'll be showing on the screen. It's not an exact walkthrough or a deployment tutorial per se, but we'll be talking about some strategies around DNS monitoring and why we want to do it this way and what are the benefits, and again some different scenarios for doing data collection. All right. So in this tutorial, we'll be covering techniques and tools to monitor DNS traffic on primarily authoritative DNS servers. This is not to say you can't deploy this on recursive name servers, but it's primarily targeted towards authoritative name server, although query collection will work equally both ways. If you're familiar with something called passive DNS, this is done at a number of measuring points on the internet. Queries are being collected on the wire or on the DNS server, and this is what we'll be talking about, to produce various statistics, metrics, and also for traffic analysis, detecting possible threats, infections, and so on. Then we'll be talking about some different scenarios on how we'll capture those DNS queries and how this can be fed into a tool called DSC, the DNS stats collector, which is maintained by the DNS OARC. And without spending too much time, DNS OARC is an organization that is a member organization focused on research, operations, and development of DNS, more specifically promoting development of good DNS practices and getting software vendors to collaborate and operators to participate. And we organize conferences twice a year where we do present a number of research papers on and around the DNS. And so we maintain a number of tools for the community, and we also have a big repository of data, which is also why we have these tools. All right. Along the way, we'll talk about some different capture methods. We'll explain the pros and cons of each, and we'll also do some live demonstrations of the tools and methods. This is all running on my laptop. I wasn't sure what the connectivity would be, so this is all running inside virtual machines. Obviously, I also have some, we have a test site I can show you. I don't really have many live deployments I can unfortunately show because they're running for customer sites, but also it's pretty easy to set up. So when you're done here, you're also just gonna rush home and log in and deploy it on your site. So overview. First, we'll show some deployment scenarios for a DSC. Then we'll show how we can explore this data using Grafana data stored in FluxDB. So to talk about how your DNS is usually set up, there are several levels you want to monitor your DNS infrastructure. And this is the parts I'm not going to talk about. In a nutshell, for most authoritative name server operators, you're going to have some kind of database. And if you're not directly serving the data from the database, you probably have an export process or a generator that's going to produce a zone file. Some of you may be running services where you don't have a zone file anymore. It might be something like Power DNS. It might be running out of a database. It could be something entirely different. You may have key material, in which case you'll be wanting to do DNSSEC signing of your zone. And if you have that and it passes all the tests, you'll want to distribute that to all of your name servers, and hopefully everything went well. So those are already things that you are monitoring, and we don't go into that. We're assuming that your pipeline for production of your DNS zones is working, it's monitored, and this is the internal processes, the sausage making part of it. Now, that's the first thing you want to be monitoring, obviously. And what can go wrong? Well, you could have a truncated file. You're familiar with this kind of problems if you're doing any kind of work in a registry or working for a hosting company or registrar, and you know that, well, if you don't test your error codes and you just write the file and it turns out you ran out of disk space, well, too bad. You might have invalid records in your zone, might be syntactically wrong because something didn't pass validation and went in the database anyway, and you produced a garbage zone file. DNSSEC signatures, are they valid? Do you have your keys in order? Are the signatures lifetimes long enough? Are the signatures about to expire, and so on? And then distribution itself, are your name servers actually functioning, and are they loading the zones? And is the clock set correctly, and so on? So error testing, validation tools, and scripts, all of those things we don't need to talk about. You're on top of this. Now, the next monitoring that most people think when we say monitoring DNS will be, let's monitor the resources and available on the server, the response time, whether or not the zones are loaded correctly, and so on. So you'll have some kind of monitoring system deployed, and you'll be doing some polling, usually remotely. You might have some agents running on the servers as well, but by and large, you'll be checking 3-4 things like reachability. Is the server answering at all? That's kind of a basic functionality. Is it answering on port 53? Does it serve the expected zones? Let's say you have a few thousand zones. Do you have that exact number of zones on each of the name servers? Are they all loaded? What if you're using a secondary DNS provider that's acting as your secondary, and you don't have access to the platform? You'll still have to do some, spot check on the number of zones loaded, making sure that they're all there. Do the zones contain the expected records? I don't know if you know, if recently there's been an improvement that's been standardized, which is zone MD, which is a record that you put in a zone as the last record, and it's a checksum of the zone of the entire set of records for the entire zone. So this allows you to verify that your zone is actually not been tampered with. I mean, this is not DNSSEC. This is just for completeness and making sure that nothing happened to the zone during the transport process. So are the zones loaded? Do they contain the expected records? And this sounds trivial, but this is the kind of stuff that many people are not doing. And they find out the hard way when they run out of disk space, or maybe, the exporter died halfway and you didn't check the return codes, and suddenly, or it died without a trace, and you didn't check that you had the right number of records, and your zone file is much smaller than before. But hey, presto, 0 return error codes. Let's just push the thing out and get it signed. So correctness. And then finally, is the answer provided in a timely fashion? So availability. just because the server answers, if it's taking 800 milliseconds to answer basic queries, either you have a network reachability problem, or the servers are overloaded, or something else is afoot, and you have to figure out what it is. And most people, for most organizations, they'll stop there. That's it, right? They've got some service monitoring deployed. They've got Nagios. They've got Zabbix. They may have, I don't know, some kind of outside Pingdom or even Datadog or some other resource monitoring service set up, but they're not actually looking at their DNS data. You may have some metrics collection like Prometheus DNS Exporter or one of these tools that pulls all this data and puts it in a database, does some query checking and so on, but you may not be going as deep as you want to when it comes to what traffic is actually being received by your DNS servers and what are they replying. So monitoring DNS traffic. There's multiple dimensions to this. The first one you'd be interested in would be utilization. So how much traffic is there? And that you could probably get away with just doing some simple SNMP or even interface statistics, get some bits per second, some packets per second, and you have a general idea of how loaded your name servers are. You can even get a baseline out of it and have some nice graphs and just say, okay, well, that's my DNS server. It's generating, I don't know, 1 megabit of traffic. It's doing 300 queries per second or whatever. Well, maybe a megabit's a bit ambitious. Let's say a few hundred kilobits per second, and you know what it looks like, but you still don't really know what's happening. You could go a little bit deeper and say, using something like NetFlow, you could look at the transports. You'd know if you were doing TCP on 53 or UDP, or if you were doing DOT, that's 853 TCP, or DOQ, that'd be 853 UDP. So you'd have an idea of what kind of traffic you have, but you still don't have visibility into the actual DNS data. What about the actual DNS content? Number of DNS queries per second, not packets per second, but actual queries per second, because with all the retransmits and TC and truncations and all the things that can happen, you're not really sure that a packet is necessarily a query and a response. I mean, you can do it if you're just doing interface statistics. You have a rough idea of how much traffic is there, but you don't really know how much of it is legitimate queries and how much of it is bogus, how much of it is just random queries or somebody probing or denial of service attack. You want the queue name, you want to know which query type this is, and you want to know the response data, the R data, and whether or not this has been replied to with a valid answer or with an X domain or even a serve fail. Any of these things you'll want to know. And here, there's not really a lot of things you can do. You're probably going to be looking at DSC, unless you've already rolled your own or you're already paying for some other service or your provider is giving you these statistics already. So DSC was originally developed by someone named Dwayne Wessels, who is now working for VeriSign, and he's been doing a lot of measurement. Incidentally, he has a little consultancy called the Measurement Factory, which produces tools, and this tool, DSC, the DNS stats collector, is now maintained by the DNS OARC. I never actually said what OARC means. It means Operations Analysis and Research Center. And this is a small piece of code written in C, and it's got a few components. One of them is the actual collector, DSC. And DSC is just a collector. It takes this data coming from a number of sources and it converts it into some XML files. Once you've got those files collected, you want to process them and you want to turn them into something usable. And for that, there's a data transformation tool called the DSC data tool. It's not very original, but you know what it's like. It's exactly what it does from the name. And historically, there used to be a DSP, DNS statistics presenter, which was written in Perl. At some point, that went away. There's nothing wrong with Perl, but it's beyond its time now. It's mostly for reasons of maintenance. Our software engineer at DNSORG decided that he'd rather write that in another language, and he did away with it. And now we have a data explorer, which is a series of Grafana dashboards running on top of InfluxDB. So if you're familiar with Grafana or these kinds of dashboard generating and data explorer visualization tools, they have a number of data sources you can connect to them. And then you have a dashboard, say, written in JSON that say, what data source do I want to look at? What columns do I want to get out? What do they mean? What labels, what kind of, measurements and transformation do I want to do with those? And this is not going to be a tutorial about Grafana because I'm not good enough with Grafana, but we'll be showing some pretty pictures. So how does this work? How is the collector set up? So if this is a DNS server, the most obvious way to do this is to run DSC on the DNS server. And you're thinking, well, my DNS server is busy. I don't want to install software on it. Well, you don't have to, but we'll get into this in a minute. This is one of the likely scenarios. There's also another way to do it, but this is very likely you'd put DSC on the DNS server because it's such a small piece of software and it just doesn't use a lot of resources. And DSC can have a number of inputs. It can take interface traffic directly. It can sniff. I don't like the word sniff. It can open an interface and with a BPF, and it can just open the interface and read the traffic from it and get the raw packets. And then it'll collect the data that is DNS specific. It has a BPF filter, and you can tune that, but it's already configured by default for most DNS traffic, TCP UDP 53. And you can adjust that if you want in the configuration. Or you could feed DSC some PCAP files. So let's say that you've already collected a large amount of PCAP files somewhere else, and you have a mechanism for delivering them to DSC because your name server is somewhere else. You could do that. You could SCP or rsync or any other kind of transport mechanism that would, hey, why not just Samba drive? Okay, that's a really bad idea. But anyway, you could feed those PCAP files into a directory where DSC could process them, and then you get rid of them as you process them. Or you've got some historical data. And finally, something called DNS tap, which is also super interesting in by itself. We'll talk about DNS tap in more detail in one of the upcoming slides. Now, you want to do something with all this traffic, all these packets. You want to create something out of it. You want to process it so you can do some pretty graphs, right? So what's going to happen is DSC is going to get all this traffic. It's going to do some, I don't think it reassembles fragments. No, but it's going to clean up some of the things. It's going to generate some statistics. It's going to look at the number of queries. It's going to keep a number of counters. And every minute or so, it's going to write a file. It's going to write XML files containing all the data ready to insert into a database. And you're thinking, why this intermediate stage? Well, this is how it's been designed. And that means there's a slight delay in getting the data in the graph, but we're talking a minute or two maximum. So it's not like real time, but this doesn't make sense anyway. What you want is something that's not an hour behind. You want to see if there's an attack. Okay, what are we seeing? Or what was this weird traffic last night? It should be semi-instantaneous, and a minute delay is pretty acceptable. Yeah.
Does it correlate the requests and responses in this file?
Sorry.
Sorry, so the question was, does DSC correlate the requests and the responses? Because there'll be two different packets in the BPF and put them into like a single entity in the XML file.
Right. So I think what we can do is probably look at some XML files. And you can see, well, there's not much in those. Okay, there's something better here. Now, this is written in, this is a timestamp, obviously. If I look at this, you can see the kind of data that goes in there. We got some PCAP statistics, we got directions, and you've got counters. It doesn't actually store queries per se. It aggregates them and produces statistics that are ready to be imported. This is why this is actually very little. If you look at this, yeah, you'll see the port ranges, all the information that you're interested in. So what happened is that in DSC, you define data sets. You say what you want to aggregate. So obviously, at the beginning, you've got the whole animal. You've got a PCAP. You've got the raw data. You run that through DSC, you turn the handle, and you get some statistics. And for that to work correctly, you have to have defined some data sets. And it will only produce statistics on the data sets you explain. So we can look at the dsc.conf afterwards. But it tells you basically all the different query types. Here we had Q type 1 is a record, I believe. 28, I never remember. But I mean, you have all the different query types here. And in TCP, how many did we have? We had one A record request. So there was obviously is going to be less traffic on TCP than on UDP. That's normal if your server is configured correctly. So this is very much an aggregate. And if you're not happy with that, you have to go back to the PCAP. And of course, if that ship has sailed because it was interface only, you'll have to adjust your data set. But no more than that. Okay. Whoop. So, and Zoom leaves its little tabs everywhere. Perfect. Okay. So we have these outputs. We've got XML files, and it'll write an XML file every minute or so. You can set the interval of how often it does that. And when it's done that, you're going to want to do something with these XML files. And so this was the collection part. Now we have an aggregation part. The idea for aggregation is that you might have more than one DNS server. Who knows? Who has more than one DNS server? Good. Right. Well, it's not a protocol requirement, right? The registries won't let you have less than two, but you could run with a single name server. It's not a good idea. But let's assume you've got 10 or 15 authoritative servers set up in either unicast or anycast, or maybe they're just pools of servers with different uses. You're going to want to run this on multiple DNS servers. And at one point, you want to aggregate all those XML files from all your name servers somewhere. So what happens is you're going to have a presenter. And this is not a strict architecture. I'm putting labels on this, but you could build a big Grafana machine. You could only for the presenting. You could be loading the data into your InfluxDB on another host. You could be doing your DSC on a third machine, and so on. But let's assume that you have two layers. You have the DNS servers and you have the presenter. You have an InfluxDB, which is the database that's been chosen for this purpose, and there's some kind of transport. And I say some kind of transport, and sometimes people go like, well, what's the preferred method for collecting your XML files? It's your choice. There is no daemon or no process that's standardly, by default, configured for carrying the XML files over. In a way, if you have enough resources, you could run everything on the DNS server and put everything in one directory. But it's a cleaner approach, for example, to have the presenter maybe be inside your corporate firewall or wherever it is and pull the data. So I should maybe draw the arrow kind of in the other direction, but the presenter would be pulling the XML files into the local file system. And as they're processed, you would be removing them from the DNS server, right? So you wouldn't run out of disk space. And of course, it's a kind of like a queue mechanism or store and forward or bufferized. If the presenter dies, well, the XML files, accumulate, then you fetch them and delete them as you go along. It's not rocket science to do that in a way where it continuously pulls in the XML files and so on, and just processes them. Once you got those files and they're coming in batches, maybe you run this continuously, maybe you're doing an rsync every, every minute or so. You're going to read them into this Python program called DSC Data Tool. Now, DSC is super fast, so it really has very little overhead in terms of resource usage on the when it's processing the PCAPs, but DSC Data Tool is a little bit more top heavy, and it has quite a few, it has a number of libraries, and it also does a number of transformations on the data, like mapping port numbers and things like that into various labels. So there's some post-processing that goes on, and it also can do some, use the MaxMind GeoIP database. So it can produce some country statistics in the data before it inserts it. So, yep.
You mentioned maximize geolocation. Geolocation is, oops, sorry.
I'll say that again. You mentioned maximize for the geolocation. The geolocation becomes less and less accurate the longer you wait to ask it. The transport, can you just do that in real time? Can I write to an NFS volume, or can I?
You could do whatever you want.
Keep it running continuously, or do I have to do it in? Is there any reason to really do it in batches, or can I just do it in real time? Stream it.
Yes. No. The answer is you could do it either way. Like I was just saying before, you could do it continuously with a socket writer, like reader and writer. You could do it with an NFS volume. NFS across the internet, my favorite. And then you could do it with you could do while true rsync sleep 5 and then copy the stuff. So I mean, you're right, the longer you wait, but in this case we're talking a matter of minutes, right? So it's not like usually prefixes don't change hands that fast in the MaxMind DB. But of course, it's a bit like if anybody's done web statistics years ago, if you had all these IP addresses and you did reverse lookups, remember when IP had reverse, like meaningful reverse? That was cute. You'd do statistics, but you'd run them maybe a month later, and then, at that point, or maybe a year later on old logs, and suddenly the IPs, belonged to somebody different and it had absolutely no meaning anymore. But in this case, if your MaxMind database is up to date and you can get a free license in most cases for, limited use, I don't really think they care as long as you, I think it's like limited lifetime, but the license key, but you can just download it for free. So I don't even realize when you have to pay them, but anyway, you can read the data into DSC data tool, and what it'll do is it'll write it into InfluxDB, and it's not super fast in doing so. It's also doing a number of lookups. It can also do, there's a couple in the manual I have to remember. There's a couple of options you can enable which will trigger it to do even more lookups and, fetching information and register AS numbers and things like that. So you have to be a little bit careful because it can really slow things down. But this is why the collector is so fast. And once you got things, in a pile, you process them as fast as you can on a beefier machine, or at least a machine dedicated for this purpose. Right. So then you want to move on to the presentation. And presentation is going to be, well, DSC data tool has done its job. And at this point, fantastic animations, you'll want to have some kind of presenting layer. And in this case is Grafana. And Grafana is going to be configured to talk to a data source on the in InfluxDB. And that means a database called DSC, and you get an API key, or rather a token, for accessing the right database. And you go in there and you just say click test, and it says, yeah, I can see all your values. And once you've done that, you're ready to load some dashboards. And what happens is there's a number of dashboards that are provided, some basic statistics on the type of queries and so on, and also a little kind of graphical chart showing the provenance of the packets or the queries on the globe based on the MaxMind database and the type of query, the breakdown, the transport, and all these things. And those are dashboards that are shipped with DSC, but you can build your own. You can customize any which way you want, obviously. Now, this is where I'm not really good at doing Grafana dashboards, so I'll show the ones we have. But if you're asking me how to create a data source, I'll look at you blank. I need to read the manual. I am really not good at this. So, but if anybody here's worked with Grafana, they know exactly how the thing is set up and how to do these things. So you import the dashboard once, and after that, it's available. And you get things like, things like that. This is an example of a statistics dashboard that'll tell you the numbers of queries per second, and I'll show you a bigger one in a second, right? All right. So just for a second, actually, maybe I should pop that up. Maybe I should bring that up on the display. I do believe I have one here. It's like in the cooking shows. Here's one I baked earlier, right? So I thought about during this tutorial to actually deploy DSC, but it's mostly Debian and Ubuntu packages and Red Hat. It's not super complicated. I'll show you the config files, but deploying it from scratch is not really exciting. And there's already a how-to that covers everything. So, but this is the kind of basic dashboard you can get if you're looking at the raw statistics. We have a number of dashboards here. We have a very basic DSC. Now there's nothing because I've been loading data from a historical source. So here I was loading data from last year from something called DITL, Day in the Life, which is a 3-day effort where quite a lot of actors on the internet, root operators, GTLD, recursive providers do captures, live captures of data for 72 hours or 48 hours straight. And then this is uploaded to DNS OArch for archival, and we do this every year for the past 12 or 13 years, or even longer, I think. So I was able to get, some of this data into Grafana, and if you're familiar with Grafana, you can see here I have about 24 hours of data. Here there's a big spike of something, I don't know why, but I can just decide to zoom on that, and I get basic statistics like queries per second by node, queries per second by queue type, and queries per second by R code, up code, and so on. This is very basic stuff and not really interesting. Then we have some client subnet where we can, luckily it remembers the last ranges. We can see the originating subnets. We can see the originating, let's see the client subnet. Here you have the client subnets that have been querying. It's not a very good way to present it, to be honest. So those are basic dashboards, and I wouldn't really use them for anything, but you get an idea of how busy and which countries are querying your servers here. You see by extension, this is using the MaxMindDB and the lookup of the origin of the subnet by country. So you get a breakdown. You can see here in this case, I'm trying to remember which data set I loaded this from. I believe this may have been Amsterdam. And you can see, I don't know what, Armenia. This is kind of interesting. Maybe I actually loaded the wrong data and I probably loaded from an Armenia server instead of the Amsterdam server. Not impossible. Right, but the point is, and this is not super exciting, but you get some pretty basic stuff. And then if you really want to see something fun, we've got a number of subnets called the statistics, a number of dashboards, sorry, which again, I'll show you how to load some live data into this in a second. Here we have something, for example, and here we have actual, see most of our, for that time period, for that name server, most of the return response codes, and you have a little legend distribution between our codes. We had no error 91% of the time and NX domain 9% of the time, and not a single serve fail or not imp or anything like that. So that seems too good to be true, to be honest. We have query failure rates by time of the day. We've got response time. Actually, this one I couldn't get it to work, but I have to look at it into more detail. We see which queries have DNSSEC OK bit. And this was used during the DNSSEC deployment, signing of the root to track adoption of resolvers that were able to do validation. And RD bit, recursion desired. Now, this is traffic from an authoritative name server. So you'd be interested in knowing, why are people sending me queries with a recursion desired bit? It shouldn't happen, right? But still, you track this and you can see if there's an increase or a trend or something like that. And then finally, one of the dashboards, there's a number of other things that are not really worth going into right now. Another dashboard which is really useful is the locations and queries. And if I actually click on data, it'll be looking better. So I can see, for example, a breakdown of where my queries are coming from. And since this is a server that's located in Europe, and I'm seeing Armenia, so very likely I actually loaded data from an Armenia name server as opposed to Amsterdam. Never mind, it was late when I did this. And the way I did it is I took all the PCAP files from the OARC repository, and I loaded this data into a directory. And then what I did is I run DSC data tool. Well, I run DSC on it. It produced all the XML files, and then I run DSC data tool on all the files. Interestingly, I had like 600 PCAPs and for about 24 hours, and I try to concat them using what's it called? There's a tool for that. Never mind. There's a PCAP tool. I think it's cap merge or something. And DSC was not happy. It produced one statistics file. So there was something wrong with the PCAP file. So I just looped it with a script. So for loading historical data, it works very well. And I was able to get these dashboards here where you can actually see what the source country is. And you can also do that you can see the response codes per IP subnet. You can see the query type. No, actually the query type, I couldn't get that to work either. I have to dig into that. I think my data set was wrongly defined, but there's some pretty cool dashboards that are basic, but you can expand upon them. And you can, of course, you can choose all your nodes in here. I decided I only have one test node. So when I set up my DSC, you can choose to have servers and nodes, because if you're running Anycast, for example, you're going to have multiple servers. They're going to have the same name. But you're going to have a different node for each location, or rather a geographical instantiation of your server. So you'll be able to separate them here. But let's see if there's actually something interesting here. Query classifications, non-auth TLD. I don't remember what that means. But you can turn those data sources on and off by just clicking on it. This is what Grafana is really fun, is you can actually just filter stuff out and say, I'm only interested in this data. And you can say, rootservers.net. So this is actually distribution of query classifications, but it doesn't tell me if it's the incoming or the outgoing. So why is that? Rootservers.net. That's actually a good one. But queries per authority, we can see the distribution of queries based on the RIR of origin. And we can see that most of the queries were originating from the RIPE NCC region, which makes sense because this is in Europe. Anyway, I'm not here to just, spend time measure tool. Oh, wow, I can measure distances. Woohoo. Okay, anyway, just to show you some of the dashboards, the sample dashboard that's shipped with DSC and what you can do with it, but it's really up to you to customize it and dig into that and figure out all the customizations you can do with it. And I think I had some last 24 hours, I had some data as well. Yeah, so I was loading real data and I actually had some queries. And this is actually from a name server in Denmark I was loading some data from. And you can see that I had some origin. I don't want to measure. Oh, it's actually really there. This was coming from client country Denmark, client country UK for some reason. But you can see it's concentrated around Central Northern Europe. And that makes sense because this is running from this is data I collected from a name server in Denmark over a few hours to see if I could get something meaningful out of it. Anyway, so what I wanted to get at with, okay, PowerPoint. Whoa. It's a huge slideshow. It's like 800 kilobytes or something. So anyway, this was just to illustrate, some of the output, make it a little bit less boring. So let's go back to the data, the collection sources for just a second. We have BPF interface, raw interface. We've got PCAP files and we've got DNS tap. So let's look at those ways of collecting data. The first one is listen on interface. The second one is to read PCAP files, and the third one is DNS tap. So method one, listening on an interface. That's, for a lot of people, the method of choice because it seems like the path of least resistance. All you have to do is go into your dsc.conf, and we're going to go over the file a little bit later. And you can say interface enp0s1 or some other ridiculous Linux interface name. Why can't we have ETH0? Give me ETH0 back, right? Okay. How many here are Linux administrators? How many of you have upgraded a system and rebooted it and find out it just got off the network because the interface name changed? Yay! We all have the scars, right? No, well, yes, FXP0 for the win. Anyway, but yes, for sure, if you're using FreeBSD, Linux won't happen to you. So, so you replace with the interface name of your server, and it could be a virtual machine, of course, and then you just run DSC, and it'll process data. Now, when using interface capture, you need the privileges to open the raw interface, right? You need to either have a DSC run as root, which is not a good idea, or you need to change the capabilities and the ownership of the device, and you can do a set cap. I can't remember the exact command, but you're able to set it so DSC. I mean, it's not the end of the world to run it as root, but if there's a buffer overflow in DSC, you'll find out. So you're better off preferably running this as a non-privileged user, and there's several ways to do it. When running in this fashion, the interface is open in promiscuous mode, and that means you're going to see all the traffic on the wire. Now, obviously, if this is a switched environment, you're not going to see much else than the traffic that was destined for your host, or maybe the virtual machines running on your host, but not much else. But at least it's not going to be targeted specifically at one destination or IP address. It's going to be all the packets in and out of that interface. And by default, it's going to be writing XML files every 60 seconds, but you can change that. So what is the advantage of running on using BPF and packet capture? It is by far the simplest method with the least configuration. You don't have to touch the DNS server configuration. You can just run that alongside your bind, your not, your unbound, your whatever you're running, your Microsoft DNS server. And you can run PCAP on Microsoft DNS server. Sometimes we're stuck with products we have to live with, right? So, and so the simplest method is you can access the raw packets before the DNS server has seen them. So if you're looking for anomalies or weird packets that trigger a crash, for instance, you'll have raw PCAPs you can work with, unless, of course, you're feeding, unless DSC is processing them directly. But you have the packets as they are on the wire. On the downside, capturing the raw traffic is kind of, it can be CPU intensive, not very much, but if you've got, 10 gigabit interface running a BPF filter on that does hog the CPU. And privileges need to be set correctly to minimize security risk. And you're also kind of duplicating the work because you already got the name server processing that and you're sniffing the traffic next to it. Okay, but at least it's super easy. Open the interface, read packets, done. The second method is reading PCAP files. Now, this kind of, well, first you have to make previously captured PCAP files available, and then you use them. You could, for example, build your setup with TCP dump or Wireshark and -G, -C to rotate on time or size, and then you could pull in the PCAPs, and then you can run DSC on them. This is if you wanted to separate your name server from your DSC collector, and you didn't have the option of installing software. Maybe you're not allowed to install software. It's just not, maybe it's an appliance, whatever, but you still can get PCAPs out of it. And you get PCAPs and you can process them, then you'd have to feed them into your DSC, and then from there, you'd get the XML files. So you could do it that way. Or you're having historical data that you want to process, just like I was doing with the DITL data from last year. And the latest PCAP file can then be transferred to the processing node. You can do this automatically. So what's the advantage of doing it that way? So again, you can, like I just described, you can use it to process data that was captured elsewhere. You can explore historical data. Let's say you're an OARC member, talk to me. And you have access to this data and you want to do some research, or you have PCAP stored because that's how your incident. Let's say you detected an anomaly on the network and you want to find out what that is, and you load the PCAP and you want to go into detail what's been happening here. I mean, normally you'd be doing this automatically, but maybe you have some old PCAPs and you want to find out what was happening, or what did the DNS look like back then. And again, it doesn't require special privileges. You can just load a file from disk and DSC can be running as a non-privileged user without any shenanigans. Now, a bit more complicated if you're trying to get PCAPs from another host in real time, and you have to basically run a script with DSC to process PCAP files every time they come in. I mean, it's not rocket science, but you have to do it correctly. Third method, which is, I think, by far the most interesting, and we'll get to for a number of reasons, is using DNS tap. So DNS tap was developed by Farsight Security some years ago, and then Farsight was acquired by Domain Tools. And the idea behind DNS tap is that DNS traffic is going to be processed by DNS server software, authoritative or recursive. And you can now build most name servers, including bind, unbound, not power DNS. Pretty much all of them have support for DNS tap. So there's a configure time, compile time option, or a module you can load that includes DNS tap support. So when you do that, it'll make your name server DNS tap capable. And DNS tap is this really nifty thing which allows you to export DNS messages, not raw on the wire, but as the name server has processed them. So it'll be generating its own view of, I got this query and I generated this response. So you're not getting what's on the wire. You're getting the DNS server's idea of what it saw and what it replied. So it's not an image, it's not a picture perfect. It's an oil painting made by the name server. This is how the query looked, and this is what I sent back. Okay, I'm just a little bit kidding, but you're not seeing all the bits and things. You won't see if there's a fragment, you won't see the window size, you won't see all these things because it's inside the name server. Now, this is not query logging. Anybody here ever tried to turn on bind with query logging? And suddenly your machine goes like, and it's like trying to trash the disk because it's just writing synchronously all this stuff to the disk, and it's like, just drinking from a fire hose kind of thing. It's not super efficient. You could also do, there's different ways to do it, but query logging is usually a debugging tool and not a statistics tool. So there's actually somebody at Orange did a comparison of DNS tap testing and this is 4 years old, so it's not super new, but it's actually not totally old either, about which servers support which kind of DNS tap, request response, and whether or not it will do Unix socket, whether or not it'll do TCP stream. This is for exporting the data. And there's a couple of, there's some information about how to configure the different tools. It's not up to date, and actually I should write to Denis and say, can you please update this? Or I should just do it. I'm maybe less lazy. But anyway, so this is in a nutshell, and I stole this from the DNS TAP website. This is basically the way it works. You have here DNS queries coming in and DNS responses, and you have a DNS worker thread inside the name server. And DNS TAP is basically it's using protocol buffers from Google, and it just creates this. It has this payload, circular processing queue, and it just sends it to an exporter that sends it outside to a DNS TAP receiver. And this DNS TAP receiver could be DSC. So it's already part of the whole process. It adds minimal overhead to the query response process because it's asynchronous, and it actually doesn't stop, queries from being, it has a queue, and it doesn't stop the name server from answering. So it's not like, oh, I can't send to DNS TAP, I'm going to stop answering queries. And it can also send it to a log file, or it could process it onwards to something else. Now, there's 3 ways you can deliver DNS TAP. You could do it over a Unix socket, which implies that your receiver is on the same host. But you could be sneaky, and you can take that and use SOCAT and feed it to another machine. Luckily, recent versions of DNS TAP also support a remote destination. But even though a DNS TAP receiver might support it, maybe the name server doesn't have the latest version of the library and hasn't implemented actual UDP or TCP remote. Big deal. Or it could be a local file, which can be useful, and then you can ship those somewhere else. So DSC is typically configured to accept a Unix socket, because if you're going to put DSC on your name servers for convenience, you store the files close to, or you store your process, or you collect the data and turn it into XML files as close as possible to the source and ship them later, then you'll do that over a Unix socket. If you want to do it remotely, you do it remotely. Now, if the collector and name server is running on the same machine, or you can send it to another host. So, yeah. So other methods of populating the data, by the way, one of them is to use DNS perf. If you're trying to do some benchmarking, I don't know if you know about DNS perf, but it's in Python. It's actually not super. It's not a super DDoS type tool. It actually tries to match its throughput to what the server is able to reply. It's more for benchmarking. But if you want to really see if a server is going to break, I think it's called, there's something else, KP something. I can't remember the name. But it's useful for crafting, testing payloads, and for example, doing a random file, and you give it a file with like a million queries for all the names in your zone and all kinds of queue types, and then you feed that to DNS perf, and you can actually use it to feed this synthetic data set into your name server, or you could give it a PCAP. But for that, there's another better tool, which is also OARC, which is called Drool, the DNS replay tool. It'll take a PCAP, and even though it was DNS queries to no specific name server, you can tell it, take all this PCAP of data and send everything to this server. So you can replay the data. And if anybody here has been doing any kind of IDS work, intrusion detection or statistics monitoring or whatever, and you're trying to test, is this going to trigger my IDS, or is this going to be detected? That's the kind of stuff you do, right? You do a PCAP, you capture the attack or something like that, and then you replay it several times until you get the effect you want. So in this case, it's a PCAP, it'll replay it, sends it to a specific DNS server, and there's a timer. So if the data set you have took 24 hours, you don't want to wait 24 hours, right? You want it to replay all the packets back to back with 0 milliseconds between each packet. It will just flood your server, or you can tell it, play it at 3 times the speed. Just like, does anybody here ever watch Netflix movies at more than 1 times the speed? 1.5? Shame on you. No, just kidding. Actually, it's like, I thought, that's kind of like, that's not how it was meant to be. And then you get kids, you grow up, you have a job, and you're like, I can watch this at 1.25 speeds and actually still get the story. They sound like chipmunks, but anyway. So here's the same thing. You can replay it as fast as you want. So notes on interface capture. And we're Oh, we got a few minutes before the break, and then can dive into a little bit more into the configuration. If you're going to run DSC on the DNS server itself, I would suggest you go for DNS tap, primarily because you don't duplicate the work. Duplicate the work. Now, if you're doing TCP dump on the server, you're close to the server, but you're not in the server. So how are you going to deal with encrypted DNS? How are you going to deal with DOH and DOT if you are looking at the traffic on the interface? Because that's the whole point, right? You can't see what's in the packets. And this is where DNS tap becomes kind of unavoidable. It's really instrumenting your DNS server where you want it to be, as close as possible to the wire. I mean, ideally, you would be able to just do after the decryption in the kernel or somewhere in the user land, and you could get the packets there. DNS tap is a little bit higher level processing. You don't have all the bits and bytes from the packet, but it's as close as you know, it's as good as you'll ever need for your statistics purposes. So if you have encrypted DNS, a lot of the interface capture methods that we've just described don't really make sense. Now, obviously, a majority of the DNS traffic is still unencrypted. It's still UDP, still TCP, but how long, right? Actually, that's something you could instrument your DNS to tell you. Look how much, you know, how many percent of your DNS traffic is UDP and TCP, and how much is DOH and DOT. Problem is with DOH is kind of hard because it's going to be port 443, so you won't know unless you're using DNS tap. But if you don't have DNS tap support, you've got an appliance, you've got a third-party name server, you may have to do interface capture. Maybe you don't even have access at all to the DNS server platform, in which case, what are you going to do, right? Best thing you can do is sniff the traffic. So one more thing, I think I'll leave 5 minutes before the break for taking questions, and then we'll break for. Am I wrong in my time? It's 11:30. No, we have half an hour left. I'm sorry, I'm looking at the wrong. Yeah, no, we got plenty of time. I'm so sorry. It's just because the sessions are lined up weird. My bad. Okay. Yes, we got plenty of time. Okay. So it's just because I don't have that many more slides. After that, I'm going to go into the DSC configuration and the actual setup and how it's built. So you could actually do port mirroring. I don't know if anybody's ever done that on a switch. Span port. So if you have a smart, if you have a switch, basically that's not something you bought for $10 and has a management interface, it's very likely it has in the chip support for what's called span or mirroring. And you can say, this port, in, out, or both, I want you to duplicate the traffic to another port. And on that other port, you'll put a passive collector, and you can be doing snort or suricata, or any kind of IDS. You could be doing generating net flow if your border router doesn't support it, or you could be doing DSC statistics on your name server. So that's still useful. I'd say it's less so than a number of years ago, especially because as more and more things move towards virtual machines, you could just capture the traffic off of a virtual interface, right? But in this case, if you really did need to do that, if you have some kind of third-party appliance doing DNS info blocks or whatever, then you'd be probably doing this kind of stuff. And by enabling port mirroring, so we can duplicate, you know, whatever we want. Now, if we had a hub, anybody remembers hubs? Anybody old enough? I don't think there's ever been anything. 100 megabit was the limit. I think when you got to gigabit, it was not possible because of the signaling restrictions. You can't have a gigabit hub. But I'm pretty sure that if you look somewhere on the net, you can buy one. Yeah. So passive collection. So after you've done that, it's a matter of configuring DSC to listen on the target port. You will have to configure DSC to actually listen to, or rather to be configured to capture data for the IP address of the traffic for the machine that you're not intercepting, that you're duplicating. So if your IP address is 1235 and the DNS server is 1234, you'll have to, in your configuration, say local address 1234, because that's the traffic you want to capture. Otherwise, DSC will say that's not me, and it'll think that's just a client. But if you say that's me, this is to know. So DSC has a chance of knowing what are the inbound packets and what are the outbound packets. Otherwise, how does it know who's asking and who's replying? I think that's pretty much all I have in terms of slides right now. I do have some links and stuff, so I'm going to just dive a little bit into the setup in the back end. And were there any questions at this point? I guess people would have interrupted me, but
Presentation, available online?
it is. Well, I uploaded this morning, latest version. It should be online, yes, very much. And I probably will upload a version later again because I'll add some more stuff. There were some configuration files I wanted to add. But it's not like I don't have that much more to add to DSC itself because the rest is on the in the links, how to set it up and so on. What I wanted to do is illustrate the case scenario for the links. Yeah, no, it's all online and yeah, for sure. And all of that is should be uploaded now. So what I wanted to look at is let's see here. If we look at for DSC, there's packages for DSC. So if you're using a DSC, well, actually, it doesn't really matter. In this case, because my machine is an ARM machine, I found out we didn't have packets for everything. So some of the packages were built and some of them I had to build fresh packages for, so they might not be in the repo. But what I did here is I did everything I should not be doing, and I'm running DSC as root. And I've got DSC running in the background, and it's collecting data. And I've also decided, because this was a small VM environment, I'll run everything on the same machine. So I didn't actually build a proper setup here on this test environment because I was thinking I don't need to go and start copying the files and doing all these things. But what we have here, I can show you the file for DSC. And once you've built it, it's really easy, or just install the package. Here's the configuration file. Let me try to move this thing out of the way. Right. Here's the local IP address configuration. You can have multiple, obviously, because DSC can be set up to listen to multiple IP addresses. I mean, both v4 and v6, and maybe you have multiple v4 addresses on your host or whatever. I mean, you could have a service IP, you could have a, what do you call it, a loopback IP and so on. So all these things would be worth monitoring. And if you're monitoring through a interface capture mechanism, you'd want to configure that IP in here as well. Or you just put a subnet, in which case it'll just consider anything in that subnet to be my server. There's a run directory, and this is actually for security. Well, security. It's to minimize damage. There's a chdir into that, but it doesn't actually chroot. So it's not like, again, don't run DSC as root if you can avoid it. There's a number of parameters for tuning the memory. The rest is not so important. And you can see there's a default BPF program, which I think, now I have to check that. I don't remember if it, yes, it is able to do TCP and UDP. I think by default it does both. So it's actually, this is kind of misleading. You think it only does UDP by default, but clearly in the dashboard, I could see both UDP and TCP. So, but you can override. If you're only interested in seeing queries, you could actually use a BPF filter like this, which would match into the UDP packet and match only query type packets. And the reason for that is that maybe you're not interested in the answers. You're just interested in having what kind of queries am I receiving. Especially the root server operators are mostly interested with that. They don't really care about the replies. They want to see what kind of queries they're getting. If you're doing analysis on, you know, trash, anybody here running, well, not a root server, but if anybody here is running a recursive name server, you're generating a lot of traffic that you're sending to the root servers, especially priming queries and then queries for domains that don't exist. If you have customers that have set up their domain and they have running .local or .internal or .mydomain or something, what's going to happen is, or that person has a search suffix in their configuration, they're going to say, I don't know, ping my server. And the first thing that the resolver is going to, the stub resolver is going to do is send a query trying to look up, is there a TLD my server? So you imagine the amount of crap, the amount of junk queries going to the root. I think it was 70% of traffic was NX domain or something like that. And it's actually something that's based off of the data sets here and using tools like DSC and others to build these kinds of reports. And so this supports the discussion that maybe recursive operators should be running a copy of the root zone on, it's called hyperlocal. Anybody heard of it? It's a proposition to just basically run the root zone on your recursive server, load it there. It becomes a sink for avoiding all these queries. And like, instead of spending millions of dollars, I mean, does anybody know how many root servers we have at this point? We're like, yeah, 13 IPs. Yeah. We have 4,000 instances or something. Maybe, I don't know. I mean, there's lots. And to deal with like the increasingly large size of denial of service attacks, which the root deals very well with, but it's still, it's an arms race and adding more and more capacity. There's some talk of saying maybe we should just make it a default feature to be hyperlocal. Start by transferring the root locally, of course, at the expense of having it non-refreshed and and all those things, but might be stale or something like that. But on the other hand, this is the kind of statistics that will support we should be doing this. Is there a question? Here, catch.
There we go. So hyperlocal worked really well in classic unsigned DNS and would have been a sensible default, but with DNSSEC, you need to refresh a little bit more often.
You do need to refresh it more often, yes.
So I'm all for hyperlocal, but then where am I going to get my copy? Do the root servers let me EXFR it? Do all of them let me EXFR it?
Currently, quite a few.
No. So
I think,
yeah, so B does.
I mean, the thing is, okay, my argument here was not to make a case for hyperlocal. My case was to say, tools like DSC and the kind of monitoring that was being done is supporting, this kind of like, should we be doing it or not? Because obviously not everybody's convinced. If you listen to Jeff Houston, he's saying, why aren't we doing hyperlocal yet? If you listen to a lot of operators in ICANN, they're like, whoa, you're being way too innovative here. Give us 10 years. No, just kidding. No, but there's caution because you're right. I mean, there is caution because if you do that and you deploy it and you tell people that's not the best practice and everybody screws up and everybody's zone expires, it's like, trade-offs. This is why having this kind of tool and all that. Anyway, long short, you can do a BPF filter here. DNS port 53 by default. And of course, you can change that if you want. And there's various options for capturing, say, DOH, DOQ. PCAP buffer size, I wouldn't mess with that normally. Increasing it may have other side effects. Yeah, like starving your kernel for memory. Drop IP fragments is usually a good idea, but by default, it's like that. So interface, I turned it off for now because I've decided to run it with DNS tap. I configured a not name server, but earlier I was playing around with interface. So I can't really tell you what happens if you define both interface and a DNS tap. I think it's one or the other. But you can specify any interface if it's a Linux machine, or you can specify a file. And I know it's a misnomer to say interface and a file, but it means I'm expecting a raw PCAP, which means it will read the file. And when the file closes or is the end of file, it'll stop processing. So what you can do is run this in a loop on a file and just do that on all your PCAPs. DNS tap. Here you can specify I am receiving DNS tap on localhost port 5353. So I'm not using a Unix socket. And what else? DNS tap network information filler. This is, I've never really understood the whole point of this, but I think it needs to know if information is missing because sometimes it's not included by the sender and so on. And there's like some filler data and I have no idea if it's actually really needed. Yeah, it's basically a dummy placeholder client name. IP. QName filter. This allows you to basically say you only want to, this is a filter you process in a data set, and this allows you to say which QNames, then only QName queries or replies matching this QName will be counted. So for example, if you're only interested in something starting with www, you could make your own filter. Now the data set, that you should read the man page, but basically, you can give a data set and say Q-type, DNS, and you can say Q-type queries only, R-code, replies only, opcode, opcode queries only, and so on. So you define categories, and this will generate rows in the XML, and then this will be put into the InfluxDB with these names and with these values. So if you look at mandsc.conf, this is explained at length. So there is no how-to guide in DSC. There's a man page that covers everything, like in the good old days. So it's not didactical. I mean, you'll have to, if none of you if some of you are already on the OARC Mattermost server, chat.dnsorg.net, there's a channel called, and it's public, called OARC Software, and the developers of the software and the rest of the community who's running this, and it's quite a large number of operators and large operators, you'll get some answer on exactly what you're trying to do. But there's a lot of explanation on the different DNS filters you can apply. And obviously, it's self-explanatory in most cases. Count all messages, popular queue types. And popular queue types is a shortcut for the stuff that people normally ask for, like not you call it NSEC3 and not obscure stuff like, what do you call it? IP telephony stuff and all that. So basically, the most, the 10 most queried query names. Query types. Oh my God, I need coffee. Anyway, A6. Anybody remember when IPv6 was using A6 as a record type? Yeah, that was a while ago. I don't even know why that's there. Chaos class. If somebody's trying to find out, chaos class is generally used nowadays as out of band signaling to find out, what is the host name and version of your name server. I like the .bind. It has nothing to do with bind, but now it's gotten abused. So, and if it's a priming query and so on and so on. So all these classes here, you can create your data sets. And by default, this is the stock stuff. It seems very reasonable. The dataset ASN, I think it's disabled by default because then you have to tell the data tool to provide that information in a different way. IDN name is actually quite useful if you're trying to find out if people are actually using it. So all this dataset stuff, play around with it. I can't tell you, what's encryption DNS. Encryption tells you like if this is actually encrypted DNS, and actually how does it? I'd have to look in the source code. When you've defined your data sets, you can actually tell it to look at VLAN tags, and in this particular case, it's completely irrelevant. I'm not going to go through the whole configuration. There's some corner cases for FreeBSD. And the output format can be either XML or JSON. And by default, it's XML. It's because the DSC data tool anyway uses XML. But if you'd rather have JSON and write your own code and process that somewhere else, put it in some Postgres or whatever, you're welcome. And the output, and what did I do? Oh, there we are. Okay, we're most of the way through, lots of comments, blah, 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 user root. The GeoIP database, you can give it this path to, if you've downloaded the database, and I do believe, yeah, I do have it. I downloaded that yesterday, and I have the latest version, and I have a license key. So but you don't need the license key to actually use the data. It's to download it. You need the license key. And you have indexers for per country and per ASNs. Client subnet mask. Yeah. This is for, I think it's for ECS. I think it is, yeah. It's basically for when your resolver, the resolver is forwarding the client subnet. Yeah. And this I don't touch because I don't understand enough. So known TLDs, there's a known TLDs file, which by default is, I believe, TLD list. I don't remember the name difference between known TLDs and TLD list, but what I did is I pulled the public suffix list and I stuck it into a file. So I have a list of known TLDs, so it knows that some of the, what's considered a top level domain, at least public suffix. And it knows to make the difference between a single label or double label as being a top, what do you call it? Public suffix. Of.
Sorry, the TLDs are a subset of the public suffix lists. The IANA file will only have the TLDs that are in the root zone, but the public suffix list has things like, well, you've got a couple there, the Brazilian ones, which are not TLDs, but they act like TLDs.
Yeah.
Like EU.org is not a TLD by any stretch of the imagination, but it's treated like a TLD.
Let me just get the file. I actually don't think it makes a difference. And I think it's a default. Why is it not copying? I'm just having a little problem with, I think it's Zoom doing something weird to my, must be Zoom's fault, right?
You'll just have to type. You'll just have to type it.
Are you kidding? Ah. Okay. No, okay, it can't because it's Linux, so it clears the terminal when you background things. Never mind. Yes. Anyway, no, the known TLDs is actually, yeah, the what is it, 1,500 known TLDs that there is actually, whereas the public suffix list is what's considered a top level registry. That's exactly it. Sorry, I was just spacing out for a second. That's DSC in a nutshell for the configuration. Now, when you've done that, you need to set up, and it'll just process happily. It's running right now in the background, and it's running with DNS tap. So where's it getting its data from? If I look at netstat, APN pipe grep 5353, it says I have DSC listening there. If I look on, I have a SOCAT. So here's what I did. I set up not, let me just keep it cold at the time. etcds, not, sorry, not.conf. So this is, I configured not to run a copy of the root zone. I mean, not very difficult. I just transferred the root zone from brootservers.net. And here's the root zone in all its glory, all 27,000 lines. It's from a couple of days ago, so I assume the signatures are still good. Well, it doesn't matter anyway. We're authoritative, so we don't validate. But all this stuff is all the TLDs there is. Just like Philip was saying, this is all the actual valid TLDs in there, plus all the glue records and everything, right? So there, it's the root zone. And I just said to Not, you're a root server by doing this. File, etc root zone domain, that's it. And then what I did is I configured mod DNS tap, which is shipped by default with modern versions of Not. Otherwise, you can enable it at compile time, but on Ubuntu and Debian, and I guess most distribution, Not resolver and Not authoritative include DNS tap. Now, why am I using Not? Because I looked at bind, and bind, at least on Debian, didn't have DNS tap enabled by default, and I really didn't feel like compiling bind. And that Not is really cool. So, one more reason. And if anybody's not using Not, it's written by CZNIC, same people who bring you Not resolver. Yes. And if you want another implementation, you go to Unbound and NSD from NLNet Labs. Okay. So mod DNS tap, you have an ID, and the ID is just something that will be included in the messages. So you know which DNS tap source this is. And it will sync, it will send all the messages to var_run dnstap.sock. But if you remember, I didn't configure DSC to listen on the socket, did I? I told it to listen to port 5353. Log queries and log responses, by the way. And then there's a template that says, yeah, but I don't even know why. I just use the example here. ID default global module mod DNS tap capture all. I have no idea what this is used for. You can have multiple DNS tap and Not has this templating mechanism, but don't bother with that. So what I did is I'm using SOCAT, which actually is doing a loop. SOCAT is taking the output of the Unix listen, well, var_run DNS tap sock, it's a listening socket, and it's sending it to TCP4 port 5353 on localhost forever. And with an interval of 10 seconds, it's polling to make sure there's, it's just buffering and it's forks in the background. So I think if we look, we probably see two SOCAT processes. No, actually we don't, but never mind. So I did that, I could have told, what do you call it? I could have told DNS tap to read the socket directly, but this is to illustrate that I could have Not running on one machine and DSC, did I say NSD? And DSC running on another machine over the network, over TCP, and it would get the traffic delivered over the socket, right? And if we do a TCP dump on -I LO port 53, and if I say dig at 127.0.0.1 NSDK, you see here, you see over, that's the actual traffic on oh, well, of course it's on the same port. Did I say port 53? It's port 5353 I want, sorry. There we go. I guess I have to generate more queries. I think it's buffering, so I'm not sure at one point I'll see something, but you should see a packet going on localhost. Yeah, this is actually not really interesting. What's more important is to show that in varlib DSC, it's collecting XML files. And oh, it hasn't done so for, no, they are coming in. The time zone is completely wrong. Never mind, ignore. I don't think it's UTC 5:45 right now. It's 6:45. No, it's 5:45 UTC. No, it's correct. Oh my God, the clock is working. Wow. Okay. I don't know if you're aware, because yesterday was a leap day. And talking about time and keeping, it caused problems. Gas pumps stopped working in New Zealand. It was quite fascinating. You'd think they've gotten it right at this point, but there's still problems with people not writing time using a time library. We can see that. Anyway, year 2000 bytes again. So I got my files, and if you look at it, they're all empty. They're all empty because there's no queries coming to this server. So I'm thinking we're going to hit the break in 10, 15 minutes. What I'm trying to do is craft a big synthetic query zone. I'll also grab some more diddle data from OARC, and I'll feed it in just to have fun and show you how to process it. I have a couple. I think I have some scripts in root. Yeah, I wrote like DSC data tool. Come on, .sh. Yeah, I have basically here. See, there's some transformations we were talking about, and this, I don't really question it. I just run it as is, because when I ask our developer, why is it like that? He says, because. So that was super helpful. But this is the kind of script we use to like loop around a number of PCAPs to load the data. So if we look, to go back to what I was saying, we have all these varlib DSC, we have all these empty files, and they're not empty, but if you look at it, they actually contain zero data. They're just the categories. It says there's nothing, right? There's no queries. So for each time interval, it's for each R code, Q type, all the different data sets we defined in our dsc.conf, we're getting empty data sets because there's no traffic. Okay? So we have to generate some traffic. So what I could do, of course, would be to say while true do dig at 127.0.0.1 NS, and I could do a 2-letter random something, but if I keep asking, I don't know, for .com done, like, okay, bit aggressive, right? It's like a poor man's benchmark. And hopefully within a minute, I should have something. I should have something showing up. Otherwise, what I think we'll do is we'll use DNS perf with a synthetic. I mean, that's the kind of queries the root sees, right? When you're not doing QName minimization, you're going to see the whole. You're going to see the whole thing. www, I don't know, ibm.com or something. Well, I forgot to say which query type I want, but by default it's A. Okay. It's taking its time. It should be up to a minute, but I mean, I should be seeing some statistics, but this is not really the way you're going to be using that. If I look in temp here on the machine, I have, oh yeah, it was Armenia. I was in Amsterdam. So that makes sense. That's why I was seeing so many queries from Armenia. I was tired when I got this, but I mean, I saw ripe.net and I said, oh, that's, you know. So here we have the PCAPs for 72 hours from DITL capture from one of those instances. And I was thinking, that's not a lot of packets I was seeing. Armenia, okay. Now in Amsterdam, I was like, it's like a few packets per second. That's not a lot. So, and I realized, well, that's because I'm looking at a name server that's not very busy. Has it done something now? Var lib DSC. No, it's not actually. Yeah, it just did it. It should have just done it now, right? I don't think it's logging anything. Okay, not super convincing. I think we're going to load some real data. So what I was going to do is I'm going to look at DNS perf, and DNS perf can be told to have a file like this. So what I can do is I can create a synthetic data set, and I'm just thinking, oh, we could just create a few. I think it'd probably actually grep ns in etc not root zone pipe grep minus vnsec. Oh, actually grep w. Yeah, I know it's horrible. My grep foo is not very good. I should do egrep. Yes, I know. At least I didn't do cat pipe grep. I know. What I'm just trying to do is trying to get some names out of this. And I mean, the idea is to ask for www all these domain names and get referrals, right? That's what we want to do because this is what the root zone does. If the root zone, I mean, at one point, .dk had an IP address. That was great. You could say ping DK, but you can't anymore. But well, it went away. They grew up. Yeah. But you could. You can't. If you find me a name, so if you can find me a TLD that answers to a ping DK dot, what? Well, that's going to be Lou records, right? Yeah. So you need single label A records. Yeah, yeah. Anyway, did it actually? Oh, it didn't generate traffic. Okay, there's something I'm doing wrong. Let's try and give us some real data then. Well, pseudo real data. So if I do a grep rsig and I say, how do we want to do that? We just stick that into /temp. Oh, pipe awk print $1, right? And what do we want to do with that pipe? Sort -u. How many TLDs do we have, by the way? It says we have 1,451. This is about right. And yes, I mean, my grep is horrible. I could probably have done this in one. But yeah, like start awking the first column to start with. But I have this. And if I wanted to create that, I'm going to create that. Oh, pipe sort -u /temp source.txt. Right, I have this. And I'm going to put www dot something dot yeah, something like that, right? And then we have to add would that be it? Yeah, we have that, right? We have 1,400 there. And then we have to randomize that. Philip, do you have a one-liner to randomize a file in the order? Shuffle, is that what it's called? Can't be, it's too long for a Unix command. Nothing would have been called like that in the 70s. You would have worn your fingers. Come on. Okay, we're almost out of time. So let me try and see if I can shuff. But is it like, oh, shuff? You're right. Oh my God. Generate random permutation of the input lines to standard output. Can I do it in place? Oh yeah, well, just pipe, I guess. Shuff. There we go. Hey, I learned something today. I was gonna like write a Perl script, as you do. Okay, and I can say cat source towards source 2, and we're not gonna count on the cell.txt and cat source. Yeah, I'm just gonna duplicate it. There we go.
Okay. So AI has an A record, so.
Really? Of course it does. And it probably added it itself. It's sentient. It does. Yeah. Ping AI. Ping DK. Oh, pin. Nope. They lost it. Okay. So now DNS perf. Let's try and feed this to our server. Man DNS perf. Yeah. DNS perf. This is a fun tutorial. Okay, so the way we're going to do this is we're going to give it a file. And if I remember correctly, we have to say S for server. A's local address doesn't really matter. And D is data file. So -D. A data file and server will normally be specified. So if I say DNS perf. Wait. No? Oh, it is there. -D /temp source.txt -S 127,001. Oh, okay, that went quick. With only 2,900 queries because there's only 1,400 lines. So I'd have to like duplicate that many, many times, right? But let's see if it actually did a dent in my statistics. We'll have to wait a minute. Otherwise, I'll have to feed that many times over I might be doing something wrong with the DNS tab. I'm not excluding that. But it seems to me like it's actually receiving something. It wouldn't be creating those files otherwise. Actually, it should say so. Right. Let's see here. Burp. Doesn't really say the source on this. Just says DSC data, PCAP stats, and so on. Yeah, PCAP stats, you'll have nothing basically because this is coming from DNS tab. So you won't have anything about statistics in terms of raw packets per second and frame seen and all that. Kind of surprised that. Or VI. Okay, it's a million lines at this point. Let's see if we can write it. Yes. DNS perf. Ah. Now it's chewing. Okay. No error. request, response, queries per second, 125,000 queries per second. Now, this is a container running inside a VM running on my Mac. So remember like 15 years ago when people were like 20,000 queries per second on the server? Whoa. Like now it's just, yeah, Python. So, and otherwise we're going to hit the break. And what we'll do is I probably can I'll try and figure out why it's not generating it because I just messed around with this morning early. So maybe I'll just revert to using DNS tab directly from a socket and not use SOCAT. There could be something hanging. Could be the SOCAT process is hung or something. To be honest, this was more a playground than anything. So I'm kind of, yeah. It doesn't seem to be reacting. Yeah, etc DSC. I think we're going to have a break in a second. Yeah. EUSR local etc DSC DSC.conf. And local address. No, it should actually be ready. varlib BSC. Everything is fine. DNS tap 127.53 on TCP. And is SOCAT. Okay, well, I'll fix that in the break. I think we hit the end of our first session. And I don't think we're going to run another hour and a half after lunch, to be honest. I think we'll run another half hour, maybe get some more examples, try and get this stuff. Oh, conference poll. I'm not allowed to see that, am I? It's okay. I'll stop the screen share here. And thank you for the first half. And then after we can take questions, I can go maybe a little bit more into Grafana. And then we'll see maybe some of the setup steps. I'll show you the links that you have to look at to set this up and how to get DSC running. So thanks for the first half and see you in, oh, it's lunch in an hour. All right, cool.
Outside when you're ready. Bring up the shots and confetti. I'll take you home if you let me. Yeah. Just promise you won't forget me. No, there's a place when you're there, so I gotta keep you there. Going crazy, and I just can't get you out of my head. I see the atmosphere. In the back, getting crazy, and I just can't get you out of my Yeah. Ooh, 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 ooh. We hit the road and we're racing, yeah. You make me super impatient, and you felt the tension, got my attention. Oh, we're just friends, but I'll never be together. Makes sense.